pulley is an object that's really convenient in physics, and if it's really convenient, probably means we're going to use this quite a bit. So this is a video about pulleys. Pulleys are useful, and for this first iteration, we're going to only really deal with ideal pulleys. Now, an ideal pulley doesn't have things like friction, and it doesn't have mass. It's sitting there as a method of rearranging a direction of force, of redirecting a force. If I've got a pulley like this, and I attach to it a rope, and I want to lift a crate, lifting this crate on its own is a difficult thing, maybe. Maybe this is like a 100 kilogram crate, about 212 pounds, 220 pounds. So I've got a 100 kilogram crate. That's a difficult thing to lift. It's difficult to pull upward. But if I can swing a rope over a pulley, then maybe I can pull over here in this direction. Now, when I apply a force this way, downward, which is physically an easier thing for me to do, that force will pull upward over here on the pulley. That's all a pulley is really doing. It's taking a force and redirecting it in some new direction. When I have this kind of a thing, I might say, while drawing a free body diagram for this guy, that I have this upward force, or this upward direction, call that my positive y. And here's where the pulley gets tricky. This axis points upward, and that corresponds to a movement of this crate in this direction. I am pulling at some angle, but it's the same force. If I pull so that there is maybe a knot tied right here to this rope, and there's another knot tied over here. If I pull so that this knot moves by 1 meter, then this knot will move in this direction by 1 meter. There's no way for it to move in some other direction. Those are linked, which means effectively my axis at the pulley curls over top of the pulley. So where it moves the rope, that's tilting the axis also. So over on this problem, over on this side, when I draw my axis, if I were doing a free body diagram, I would just have my y-axis point that way. And what I need to recognize, the biggest thing, is that these two are the same axis as each other. This will make a whole lot of sense when we start doing problems with this. So I'm going to kind of give a very beginning situation of this. Maybe I have a box like this, attached to it is a rope. Rope goes over a pulley. And we'll do a triangle mass down here, and this thing is sitting maybe on a table. So as this mass moves downward, this mass will move to the right. When I draw a free body diagram for this mass over here, I would have my positive x-axis this way, because that's the direction of motion. And that makes my positive y-axis this way. So a free body diagram for this guy is going to have those axes. Over here, my free body diagram, this x-axis I can think of as kind of continuing on, and then it meets that pulley and it wraps right over it. So when I do an axis for this one, I need downward here to be my positive x-axis, which means to the right will become my positive y-axis, which is completely fine. There's nothing saying that x has to be horizontal, that y has to be vertical, that they have to have some kind of anything. The big thing that I've got with this is just a motion. Again, if I draw a knot on here, a motion of that knot to the right has to correspond to a motion of that knot downward, which means those directions, they have to be linked. they are one and the same. That's it with pulleys. The next video is going to work through examples specifically and get you kind of moving with this idea. For right now, this is where we are.